everybody. In this video, I will be talking about the fundamentals of computer networks. So, the computer network started in the late 1790s when the first telegraphs were invented. Later on, you already know that Alexander Graham Bell invented the telephone. So, without wasting any time, let's get back to the topic. First of all, how will you define a computer network? You are connecting simple, basic two computers. That is also a network. And how will you define the quality of communication? That will be done by the speed, by the accuracy, by the reliability. So, as I've written over here, jitter, timeliness, accuracy, and delivery are the factors which determine effectiveness of communication. Another parameter of measuring the network quality is response time. It is the time between the request and the reply. Moreover, you can also measure quality on the basis of security, on the basis of performance, and security itself is a very large topic. People have written separate books on security, cryptography, digital signature, Java cryptography, Python cryptography. Okay, this is a simple basic network which you can see on your screen. This is a receiver, and as you can see that a mainframe computer is sending to the receiver. So this is a simplex communication. Simplex means that data is getting transferred only in one direction. Half duplex means that either the sender or the receiver can send, but only one at a time. Both of them will not be able to send. And full duplex means that both of them can send at the same time. The best example is a mobile phone. Okay, so one of the basic examples of simplex communication is the communication between the infrared remote and the television. And okay, now another thing is that how will two computers communicate? I mean, you already know about Apple Macintosh, you already know about Linux, you already know about Windows. So how will they can communicate with the help of a common encoding? It can be ASCII encoding, it can be ADIPAC encoding, it can be UTF-8 encoding, UTF-16, UTF-32. The latest one is UTF-64. But practically, in terms of implementation, if I speak, then UTF-8 is more popular. Okay, now moving forward, those are very large topics, and we'll be discussing them in details in the future. Okay. Uh, so how will you connect a network? How will you design a network? That the simple answer is a topology. Okay, so there can be star topology, tree topology, mesh topology, ring topology, bus topology. Already these topics are covered in different books. You take any book. Okay. Anyway, this is a simple example of a star topology. As you can see that this is a central computer and two computers are further connected to it. And this is a mesh topology where three different computers are connected together. And now from here things start to go interesting, because as you can see that there are four computers over here. Okay, and this is a mesh topology because every node is connected to every other node. Okay, and so this is again star topology, ring topology over here. Okay, and so this is a bus topology. But if I go back to my material, as you can see that I've written it that if there are k number of nodes in a network. Okay, I'm just giving you an example. If there are k number of nodes, then the possible number of links can be k into k minus 1 by 2. So here in this figure, as you can see that I have got four nodes with me. Okay, let me come down. I have got four nodes with me. So the possible number of Connections can be 4 multiplied by 4 minus 1, that will be 3. So 4 multiplied by 3 divided by 2. This will equal to 12 divided by 2, which is equal to 6. So I think I have made it clear. So moving further, okay. So different topologies have their own advantages and different disadvantages, but this is a very beautiful photograph. Here you can see that there is a hybrid topology. Here is a ring topology which you can see. Okay, here is a bus topology which you can see. Then this is a star topology over here. So I have combined the different topologies into one. And types of network. Okay, so this topic is already covered in most of the study material which is available on Google or books. So there can be local area network, wide area network, metropolitan area network, personal area network, global area network. But first of all, I will start from wide area network. But okay, so wide area network is actually important because it started with telephone communication. Most of and even today we have got telephone lines which can connect us. I'll call it thousands of kilometers away. So even today, the backbone of telephone communication is WAN or wide area network. And yes, it did start with ARPANET. Rather, I'll call it the. I'm sorry, I'll call it that it started from telephone communication, and later on, ARPANET did actually use it. Local area network. Local area network has speeds of minimum of 100 megabytes per second. They can go up to 1 gigabyte per second, 10 gigabytes per second, 100 gigabytes per second. I will not comment on the speed because as of June 2022, still the hardware technology is improving, still the network technology, or I'll call it the network hardware, is still improving. So daily we are getting a new records for speed. But the only thing which I will say is that yes, local area networks are used within an organization, or for example within a company or within a campus of a university. Then comes the metropolitan area network. Okay, so they fall in between local area network and wide area network, and these networks are spread over a city. For example, they are spread over a radius of around say 50 kilometers or something. And metropolitan area networks, yes, obviously they are not limited to one university campus or whatever. So that is why they cover more area, and you can connect different networks together, or I'll call it you can connect different local area networks together to form a metropolitan area network. This can be done with the help of a router. We will be studying router in our future videos. A router, for now, the introduction of router is that it is a network layer device, but it can also work in physical and the data link layer, and it will route the packets from one network source to another network destination. And then comes the OSI model. Yes, we do have TCP/IP model also, and obviously TCP/IP model is more popular nowadays. But the reason why OSI model failed was that I'll not say that some model is more technologically superior or some model is technologically inferior. But the reason why OSI model could not become popular was that it came late into the market. But anyways, if you have to prepare for some government exams or if you have to clear some technical interviews, then you should know the different layers of each and every model. So starting from the physical layer, in the physical layer you have got bits, and okay, so it is responsible for sending the raw bits from source to the destination. And as I've already explained you, simplex, half duplex and full duplex. So these kind of different network mechanisms are decided by this layer only. Different types of network topologies which we have already discussed: star topology, ring topology, mesh topology, bus topology, hybrid topology. They are also defined by this layer. And text or whatever, audio, video, image, sound. Nowadays even computers are also moving towards smell and touch. So everything is represented in the form of zeros and ones, which form a bit, until unless you want to work on a quantum computer which works on the principle of a qubit. And even colors, as you can see that you can see different colors on your screen, so they are also represented with the help of combinations of zeros and ones. And RGB, which is written on your screen, is red, green and blue. YCM stands for yellow, cyan and magenta. And data link layer, in data link layer, mind you, you are using frames. So if there any such terms comes up, that what is packet, what is a frame, or what is a bit, then you have to correspondingly think that a packet is in network layer and a frame is in data link layer. Okay, so coming back to the data link layer, so this layer increases the reliability of the physical layer. And as you can see that different layers are, yes, they are actually interconnected with each other. And this layer, the data link layer, works on the flow control, error control and the access control. These are very large topics and we will be covering them in our future videos. Flow control aims to have an optimal data rate. It means that the sender should not send at a speed at which the receiver is not able to handle it. And if the sender is sending too fast, then it can be a problem for the receiver to properly compile it or to properly save it. And another aspect of the data link layer is the error control. So there are different mechanisms for error detection and correction, which we will be discussing in the future videos. They are checksum and cyclic redundancy check. Then comes the network layer, which is the core and the most important part of the OSI model. So it performs the delivery of packets from the source to the destination, and it also performs the logical addressing. But nowadays you already know that IPv6 is coming up, and IPv6 is of 128 bit as compared to the address of IPv4, which is only 32 bit. So this layer performs and IPv6 is supported by most of the major operating systems like Windows, Linux or Apple. And let us assume that we want to send a data outside our network. For this we need IP address. Logical address adds an extra header to the packet coming from the transport layer. So if the header is added, it also means that an extra address is also added. And there are different routing algorithms, the distance vector routing, Pelmet, Ford routing, that I will be explaining you with photographs in the future videos. Transport layer. So transport layer performs process to process delivery. A process is an application running on the system. So anything which is running, okay. So one IP address, let me come back to computer networks. One IP address can have multiple ports. One IP address can have multiple sockets, and a unit address of process called service point addressing. It is also called port address. Okay, so the address of a process is called a port address. Okay, and port can be hardware port also. Okay, so the address of the okay, so it performs segmentation and reassembly. For example, you want to send very large file on the network. So you will be dividing that large file into multiple smaller files. For example, the size of your file is 100 gigabytes. You will be dividing it into small sizes of 10 kbs. And this is just an example, and they will be assembled and combined together at the same sequence at the receiving side. So segmentation at the sending side, segmentation, I'm sorry, is done at the sending side, and reassembly is done at the receiving side. So the transport layer can be both connectionless and connection oriented. Connectionless means that if it means that there are multiple ways for one packet to go from one source to the destination, and if one uh, path gets destroyed, then automatically a new, or I'll call it an alternative path is used. And any kind of permanent connection is not established between the sender and the receiver in connectionless transmission. And message is sent directly in connectionless transmission, but on the other hand, in connection oriented communication, for example in telephone, there is a dedicated path or a dedicated route which is established between the source and the destination. And we also do flow control and error control in the transport layer. Anyways, those are last topics, and surely I'll be making detailed videos on that with solved examples. The next one is the segmentation layer. So it is responsible for synchronization and the dialogue control. So session layer allows two segments to maintain a dialogue, and two systems can maintain a session in a dialogue control. A dialogue is a simple communication between two segments. And already I've explained you half duplex, full duplex, and checkpoints are also used for synchronization. So for example, you are sending a very large file of 100 megabytes, and you are dividing it into small 100 segments of 1 megabyte. So after every one segment, you will be sending an acknowledgement. It is to ensure that how much is received and how much is not received. Next part of the network is presentation layer. So it deals with the semantics and syntax of the information. So this layer will perform compression, encryption, and translation. Encryption was derived from mathematics itself. I tell you, you have to study minimum two or three books if you have to study, if you want to learn encryption properly. And okay, so this example also I've already told you that you have got different operating systems and different hardwares from Apple, Intel, AMD, or Samsung Exynos series, and how will you communicate? So there has to be some common language or common encoding of computers in the form of zeros and ones. And let me explain encryption in a small paragraph. Anyway, it is not possible. So you are uh, converting your data into a form which only you or the receiver can understand. Eavesdropper on the network cannot understand it. So reverse of encryption is called decryption, and it is of many types. I have written it. It is of two types, but basically it is lightweight encryption, heavyweight encryption, hashing, symmetric key encryption, public key encryption. So in public key cryptography, data is encrypted with public key of the receiver, and it is decrypted with the private key of the receiver. And vice versa is done in digital signature. Then the TCP/IP model I will be discussing in the next layer, and people have actually written books on TCP/IP model, which is obviously very large. And okay, compression is also performed in this layer. It means reducing the size of the data. So okay, so this is I think presentation layer. Okay, coming back to the application layer. Application layer enables a software or a user to access the network. The different softwares and protocols needed in application are needed in application layer. Network virtual terminal is a software version of physical terminal. Users can remotely log in. The best examples are Red Hat Linux. The best examples are mainframe emulator. This layer also provides email services, directory services, file transfer access, and management. So practically, I'll call it, it handles the entire software part. And thanks a lot for your time, and goodbye.